So we've talked about multiplying 2 by 2 polynomials, binomials times another binomial. So what happens when we make that a little bit bigger? So on this page, we're going to be talking about multiplying binomials and trinomials. So in this case, thinking 2 times 3. I'm going to show you first the box method because that tends to be more the preference. If it's not, that's okay. I'll do example 2 using a different technique. But a lot of people end up liking the box because it's a little more orderly. So first and foremost, the box. Because we're multiplying a 2 by 3, that means our box needs to change a little bit. And I'm going to make a rectangle, either 3 by 2 or 2 by 3, your choice. I'm going to choose to go this way. But now that I've set it up like this, that obviously means the 6x squared, the negative x, and the 2 have to go along the top. And then in this case, the 4x and the 2 have to go along the side. You can't wrap the function around the corner. So 1 on the top, 1 on the side only. Now, the only difference to this multiplication is that now you have more terms to multiply. Other than that, everything else is the same for the box technique. So multiply to get in, and then add those up to get out. So 24x cubed for that first one, negative 4x squared, 8x, 12x squared, negative 2x, and positive 4. Now we're looking for like terms to get out. So 24x cubed is all by itself. Then we've got these two, negative 4 and positive 12 will give us positive 8x squared. Don't add the exponents. We're only adding coefficients here. And then positive 8 and negative 2 will give us positive 6x and then plus that 4 on the end. And that's it. That's box method for binomial times a trinomial. Now, if you're not a fan of box method, that's okay. If FOIL is more your preference or you just blatantly don't like the box method, there is another technique. I like to call it the clamshell. You don't have to do that at all. It's basically a distributive property done twice, which is technically what FOIL is as well. But all we're going to do is we're basically going to do the same thing as box, but it's going to look a little different. We're just going to simply take the first term and distribute it to every term in the second set of parentheses. So if I do that, I'll get 7x cubed minus 14x plus 49x, and this should be x squared. Sorry, 7x times negative 2x. Then we're going to do the same thing. Maybe I'll change colors here, but now we're going to take this second term, the negative 3, and multiply it to everything in the second set of parentheses. So negative 3 times x squared, negative 3 times negative 2x, and negative 3 times positive 7. Now, here again, if you're a box user, you'll notice that what I have in blue would have been probably your top line, and what I have in the reddish color would have been your bottom line. Again, just a different organizational strategy. Putting it all together, we're still going to combine like terms. So we get 7x cubed, let's see, minus 17x squared, plus 55x plus 21. So maybe try a box for one and the clamshell method for the other, or if you really have a preference for one or the other, but try the bottom two examples and then check back in with the video to check your work. Good luck. So I'll do the box for the first one. So 7k squared along the top, negative 6k, negative 6, 2k, and negative 4. And then quickly filling in. And again, from here, all we have to do is combine like terms. So as has been the precedent here, the diagonals end up holding them. Again, watch out because that will not always happen. So we do have to be careful to check all around for like terms. All right, and then for the bottom one, I'll do the clamshell technique. In this case, do the first set, so that'd be 2x cubed and negative 4x squared. I'll just keep using different colors. Since I went 3 to 2, this is going to look a little bit different than that first time we did it. 12x squared and plus, nope, I'm looking at the wrong term. 6x times negative 4 would give us negative 24x. And then one more distributive property, negative 8x and negative positive 16. There we go. So now combining like terms, we will have 2x cubed plus 8x squared minus 32x plus 16. All right, then our last page here for today has more multiplication. So this is kind of just starting to mix it up. I would really like for you to try these examples on your own and then use the video as a way to check your work when you are finished or if you really get stuck with something. So hopefully you did just that. You tried each of these and are coming back to check now. For example 1 here, in this case, we just have a simple 2x that just needs to be distributed. Some people, now that I've shown box, will go ahead and build the box for that. That's totally up to you. I'm just going to go ahead and simply distribute in the 2x. So we get 6x cubed minus 8x. Okay. For example 2, same thing, just a little bit more variable work. So multiplying our coefficients, we get 8. And then we add the exponents because we're multiplying. X to the third, y to the fourth, minus, in this case, 4x, just add an exponent onto each one, x cubed, y squared. Now, for examples 3 and 4 here, now they're adding in this plus and this minus in between. So in this case, we kind of have to think about PEMDAS. What has to occur first? And parentheses obviously first. So in this case, if we were able to simplify within the parentheses, we would. But in this case, we can't because there's no like terms in them. So then we drop down to exponents, which are just attached to variables. So we can't do anything with those as of right now. And then we drop down to multiplication and division next. No division yet, luckily, but we do need to multiply before we do any adding and subtracting. So really, this is just a bigger, badder problem of the first two. We're going to distribute in each of those first two. So we'll get 6x cubed plus 10x to the fourth plus 4x cubed minus 24x to the fourth. Now you can see the parentheses are gone and everything is either addition or subtraction, so we're just simply combining like terms. So 10x to the third minus 14x to the fourth. Note, again, we're not changing exponents at this point because we're adding. The bottom one, we have to be a little bit more careful when we do this second set because of this negative sign. So when I distribute, I'm going to take the negative as well as the 4x squared through. So in the first one, we get 3x cubed minus 2x squared. But in the second one, we're going to do negative 4x squared times 2x, so negative 8x cubed. And then negative 4x squared times negative 1 gives us positive 4x squared. Here again, parentheses are gone. We just have to watch our signs and simply combine like terms. So 3 and the negative 8 will give us negative 5x cubed. And then negative 2 and positive 4 will give us positive 2x squared. Note between these last two examples, one is in standard form, one is not. Just be careful of how you're being assessed. Watch for any directions that tell you must follow standard form, or if it doesn't say, then it doesn't matter. You can write it in whatever order you want.